Hi, folks. Thanks so much for joining me today, and welcome to my EWTS presentation, Applied Research within the Home Visualization Space. Today, we'll be talking about some of the toughest challenges both Wayfair and other e-commerce companies face, how augmented reality is a useful tool in mitigating some of these customer issues, and how Wayfair continues to experiment and iterate in the space. But before jumping right in, I wanted to introduce myself. So, hi, my name is Nicole, and I work as a creative technologist on the research and development team called Next within the furniture e-commerce company Wayfair. Wayfair Next is a team focused on using emerging technologies to discover and catalyze new paradigms in home and retail. We call our process the 12-week hack. Every quarter, we pursue a few explorations with the goal of taking an abstract idea or problem and creating something tangible out of it. For the current evolution of our process, projects fall into one of two buckets. Near future ideas result in a working prototype consisting of a set of core algorithms. For longer term ideas, we try to illustrate the concepts through videos, presentations, and documents to influence the larger organization. A few examples of our far future explorations include thinking about how we can use generative adversarial networks to synthesize imagined product imagery, discovering how we can create playful interfaces using projection mapping and 3D printed dollhouse furniture, and exploring how you can feel textures on your phone. Today, I'll be giving you a glimpse into some of our near future projects, each spanning the course of about 12 weeks. To start off with, I mentioned previously that Wayfair is an e-commerce furniture company. So what does that mean? E-commerce is a super interesting space because you don't get all the affordances of physical shopping. It's especially interesting for furniture because purchases tend to be bulky, large, and expensive. Think about the last time you bought a large furniture item online, if you've ever done that before. If I was looking to buy a sofa, I would want to make sure that the item I get is the perfect color and that the style fits with any existing furniture I already own. The size of the item is important too, especially because it's expensive and may be harder to return. I want to make sure it fits in whatever space I've already allotted. And of course, comfort and material quality are also super important. For a couch, I might be looking for something that isn't too stiff with a good amount of plushness that would easily seat 3 people. When you go to a physical store, you might be able to determine some or most of these things very quickly. I can sit on the couch in the store and figure out if it's comfortable, for instance. But how can all of these things be conveyed through only online means? Well, the web browser is crucial to the e-commerce experience. It's the medium in which you browse and find exactly the product you're looking for among the millions and millions of items that could possibly exist. However, if you were looking to buy a sofa on a website, you would first take a look at a few static images of the sofa, maybe read a few reviews and look at a few review images, and then try to imagine what that sofa could look like in your space. But what if you could take shopping beyond the web browser so that you wouldn't have to imagine what the sofa would look like in your home? This is where tools like augmented and virtual reality can help enhance the e-commerce shopping experience. Augmented reality is probably a tool familiar to most of you. When I was interning with Wayfair back in 2017, the first few augmented reality experiences were just cropping up. Now, they're much more commonplace and have risen drastically in popularity because AR is accessible to anyone with a smartphone. At a high level, augmented reality brings the computer-generated content to your current space, like seeing Pokemon in Pokemon Go standing on the floor in front of you, or taking a selfie with a Snapchat filter on. Everything is layered on top of your current camera feed. Virtual reality requires a headset because it needs to be powered by the graphics component of your computer. It's different from the previously mentioned augmented reality in that it isn't adding elements to your real world space, but rather taking you into a completely unrelated space where you're surrounded by 3D graphics. The best description I've ever heard about the difference between AR and VR is that AR is layering on top of the real world, whereas VR is taking you into a dream that's all encompassing. I think the GIF below does a good job of showing how the 3D paintings you create in the Tilt Brush app completely surround you. So how are these two tools relevant for Wayfair? And how can they help customers better visualize furniture in their homes? As I mentioned previously, a huge consumer problem for an e-commerce company is that customers are unable to see physical furniture pieces. From just a picture on a website, it can be hard to understand things like just how large an item might be and whether it fits stylistically with other elements of your home. Because augmented reality allows a user to overlay items at the correct size in their own space, it seemed like a great way to mitigate some of these problems. So in 2016, Wayfair launched the View in Room application within our mobile apps, which utilized augmented reality in our large 3D model furniture database. With View in Room, customers could place a virtual furniture item, like the coffee table you see here. They could then move that table around, rotate it, swap it with a few other products, and even walk around it to view it from different angles. By taking shopping beyond the web browser and into the customer's homes, We help customers be more confident in their purchasing decisions, better ensuring that the item that they wanted to buy would fit in both size and style with other furniture they already owned. For a company like Wayfair, virtual reality is useful because it helps unlock an immersive life-size design experience. Some of our experiments in this space include creating a feature called 3D Room Planner, as seen in this image on the left, where a user could go online and in their web browser, they could plan their space in the 3D rendition of their home. The experience on the right, VR Room Viewer, took this one step further and allowed a user to wear a virtual reality headset and then step into the space that they just created online. Instead of guessing at the scale of items, users could just walk up to the items they placed in virtual reality and get a better gauge for their real life sizes, viewing products from different angles in a more natural and intuitive way. This immersion was an enhancement from the static browser experience because users could decorate a full room more easily and understand how furniture pieces could fit next to each other. So, as you've seen, Wayfair has enhanced the e-commerce shopping experience to solve problems like size and scale by using tools like augmented and virtual reality to take shopping beyond the web browser. As I mentioned previously, I work as a member of Wayfair Next, the research and development team at Wayfair. Our goal, as our name suggests, is to continuously think about what's next and to push the boundaries of tech to solve consumer problems. Because AR and VR are such nascent technologies, they're ripe for innovation, so I'd like to share some prototypes we've been working on recently in this space. Augmented reality, like Wayfair's View and Room feature, allows you to overlay computer-generated items on top of your space, like the Adirondack chair overlaid on this patio. One of its big benefits, as I mentioned previously, is placing objects in your space at the correct scale, which looks to solve spatial fit, a key user need for e-commerce. But a core component of AR is that it requires the user to stand directly in front of the space they want to decorate in order to furnish it. But what if I wanted to take a photo of my living room and then go and sit and decorate it in my office instead of having to stand in my living room and hold an iPad? Or what if I wanted to send this snapshot of my space to my mom who lives across the country and have her decorate it for me? This is a capability that augmented reality doesn't have today. It isn't portable and it's tied to your current location. So the question of how to make augmented reality portable was one my team wanted to solve. We envisioned a magical experience called an interactive photo, where a customer could take an unassuming, normal-looking photo of their living room, open up that photo later on a different device like a laptop, and then be able to move and rotate pieces of furniture around in the photo, all at the correct scale. They could then share this interactive photo with their friends and family and have them edit their space, making augmented reality a more portable and collaborative experience. So how do we go about solving this problem? At a high level, in order to build out this portable AR experience, we needed to capture a slice of the real world as the customer captured a photo of their space. When they wanted to reload this photo later, we would then reconstruct this captured slice of the world. So our goal was to make this process as intuitive and invisible to the user as possible. So when creating an interactive photo, the user would first open up that view and room feature within the Wayfair application. Just like they would normally, the user would be able to stage items like in any other augmented reality session, just like how this user has added an Adirondack chair. And after they were happy with their setup, they would press the capture button. And this is when the magic would happen. Behind the scenes, the slice of the real world would be captured through just 4 pieces of information: the location of the phone camera and the virtual furniture item, a snapshot of the background, and the location of the floor. Later on, when the user wanted to decorate their space, possibly on a different device or in a completely different location from where they took their original photo, they would then open up their interactive photo. A 3D scene would be reconstructed mimicking the captured slice of the real world. Because the saved information captures the relationships between the camera, the 3D model, the background, and the floor plane, users are able to move furniture at the appropriate scale and depth without having to be physically present at the location. With this experiment, we wanted to solve for the need for portability in augmented reality, making it easier for customers to both visualize items in their space on the go and even collaboratively design with friends who live elsewhere. For our next experiment, we wanted to tackle photorealism in augmented reality. 3D rendering is ubiquitous. It's present in media from both movies to video games and even more. Within e-commerce, and particularly for furniture, which tends to be heavy and expensive, it's become an alternative to traditional photo studio setups. Previously, for scenes like you see in these 2 lifestyle images here, you'd have a photo studio and all of the pieces of furniture would have to be shipped to and assembled at the photo studio location. From there, a host of experts might be there to light the scene, arrange the furniture, and capture the shot in person. But instead of these traditional setups, which can be expensive as you might expect, e-commerce companies like Wayfair have switched to using 3D modeling because it's more convenient and flexible. For instance, you can quickly add seasonal specific decor to both of these scenes with having to restage them physically. These two Wayfair lifestyle images are examples of just how photorealistic 3D rendering can look. Despite all of these improvements in 3D graphics, however, graphics in AR can be quite lacking. Augmented reality experiences need to use lower fidelity models than the 3D models you saw in the previous slide. This is because AR tends to run on mobile devices, and this hardware constraint requires that we create downscaled versions of the models to work on the everyday phone. As a result, important features like transparency, reflections, accurate shadows, and fine detailed materials are all features that can be lost in the process. For instance, if you only saw this product in AR, like in the picture on the right here, you'd be misled to believe that this is a purely metallic table with no glass tabletop, unlike the product image you see on the left. Though augmented reality is still useful in helping to understand scale, how could we better help users visualize what an item is supposed to look like in their space? Well, with a company like Wayfair, if a lower fidelity model exists in AR, there is a high likelihood its higher fidelity equivalent exists for lifestyle imagery purposes. And this led us to our next question. How could we make augmented reality look more realistic? Could we create more photorealistic output for AR by using these pre-existing high fidelity models? So crucial to our next experiment is the concept of a proxy. The lower fidelity AR models that customers use to place things in their space are super important. Even if they at times lack visual realism, they give users a sense of the scale and location in space of the product they're placing. However, the AR model that the customer places doesn't have to be the end model that they see. This lower fidelity model could then act as a proxy and be swapped with its higher fidelity equivalent during the creation of a fuse photo, which is the next exploration we'll be talking about. So how does a fuse photo work? Well, the foundation of a fuse photo is actually just an interactive photo. So the user will stage an interactive photo as the first step, placing a lower fidelity furniture item in their augmented reality scene. This is no different from what we saw before, where users can add, move, and rotate products. When they're done, they can press the capture button and all that information will be saved. However, instead of just living as an interactive photo, all this information is sent to a 3D rendering software. There, a scene is created to match the ones the users had staged, including information about the camera and the lighting. The low fidelity model is swapped with its higher fidelity counterpart and placed at the correct location in space. We also modified the photo backdrop to act as an environment map, which allows for the capture of bounce lighting for more accurate translucency and reflections via image-based lighting. When the render returns, this results in the fuse photo you see on the right, which shows up on the user's phone about 15 seconds later. As you can see, it accurately captures product details, including the glass material properties of the product, as well as reflections and bounce lighting from the surrounding environment. Upon conducting a user study, we found that fuse photos were perceived as significantly more photorealistic than their AR counterparts. Crucially, they were also perceived as more representative of the product being sold. With the fuse photo, 3D experts and non-experts alike could create more photorealistic designs from augmented reality with just the click of a button, increasing a customer's confidence in their purchase. For the final prototype that I'll be sharing with you today, we wanted to widen the space in which you could design. So think about the difference between capturing a single photo versus an entire panorama. With just a little extra effort, the panorama allows you to see so much more of a scene than a single photo would. Similarly, though AR experiences allow you to move physically to see the rest of your space, it can be hard to get a comprehensive view of multiple products because you're limited to the camera's field of view. This is particularly painful if you're looking to design an entire room or a large space. Think a banquet hall or hotel lobby, for instance, as you might want to see how all of the items fit together in a single image. But instead of taking just a single photo, could we create a different input to unlock designing at a larger scale? Well, today, advances in 3D capture technology have made scans of real estate feasible for the average consumer. Companies such as Matterport, as you see in the video here, have even developed solutions to let customers scan their homes with their phones in just a matter of minutes, lowering the entry gap for experiences that leverage context from the customers at the home scale. This is why we created a DIY interior design tool called Home Studio, which allows anyone to stage any publicly available Matterport scan and create photorealistic visualizations directly from their browser. You can take a 3D scan of your space, like this Redfin scan of a Boston apartment, move around in the space by pressing the various waypoints, furnish it with a catalog of thousands of products, as you see on the right, and then produce a render. So when the user finishes staging their scene, they'd click the capture button and the scene would be sent to a 3D rendering service, where it creates more photorealistic output, just like you've seen with Fuse Photo. The user can then view completed renders in their gallery, as well as save and reload previously designed scenes. By taking advantage of the viewer's built-in features, users can even use their immersive headset of choice to jump inside their creations and assess their designs in virtual reality. They can look around similar to a 360 viewer and move between different waypoints captured in the 3D space. Our goal in creating this tool was to decrease the 3D skill barrier required to create photorealistic visualizations of home goods in physical spaces, so even non-experts could bring their designs to life in just a matter of minutes. These photographs are some output renders created by folks without any 3D knowledge. By changing the input of our app from a photo to a 3D scan, we empower anyone to create room-scale photorealistic visualizations of their spaces. Quotes from some of our users thus far include that it captured what the room would look like in real life, and that the tool acted as the final step to be confident that they've made the right choices. Thank you so much for taking the time to listen to me speak today. We introduced some of the toughest problems faced by an e-commerce company like Wayfair and spoke about how tools like augmented and virtual reality take shopping beyond the web browser to help solve some of these problems. We also spoke about a few prototypes that Wayfair's R&D team, Wayfair Next, has created to address the issues of portability, photorealism, and room scale design. The last thing I wanted to plug is that Wayfair Next is hiring. Our core competency is centered around engineering and the ability to build, with a focus on the discovery, ideation, and prototyping part of the product creation process. If this sounds like the right fit for you or anyone else in your networks, please reach out if you want to learn more. And of course, feel free to reach out to me on LinkedIn with any other questions you might have. Thank you again, and hope you enjoy the rest of EWTS.